Hey guys, what's up? So today we're going to be looking at equations, all right guys? And it says the equal sign is used to denote equality and it means is equal to. So everybody should know what the equal sign looks like, right? It's that little equal sign that you see there. And an equation is a statement using an equal sign, right? And it is a statement of an equality relationship between two quantities or expressions. A linear equation with one unknown is known as an equation which can be written in the form, and this is the form here, guys, ax plus b is equal to 0, where the left-hand side is equal to the right-hand side. And that's pretty much how most equations look, and where a and b are real numbers, right? So it's a part of the real number set, and x is the unknown value. So for example, we have 3x plus 5 is equal to 8 here. That's a good example of this, okay? Or you can say 2x plus 2 is equal to 0. That's an example as well of these equations, right? So let's solve these two equations down here, guys. Let's just increase the size of my writing here. And we have the first example here, which says 3x plus 5 is equal to 8. So let's solve for x, guys. Okay, so the first thing we're going to do is we're going to say 3x is equal to 8 minus 5, right? Because when you carry the 5 to the right side of the equation, the 5 becomes negative instead of positive. Then we end up with 3x is equal to 3. And then we're going to divide both sides of the equation by 3. And then we're going to end up with x is equal to 1, right? Easy, right, guys? Then for this one now, guys, we are going to solve for x. So the first thing we're going to do is we're going to say 2x minus x. We're going to carry this x over to the left side. Then we're going to say 3. We're going to carry that over to the right side, and we're going to get negative 1 minus 3. So the 3 becomes negative. Then we're going to get x is equal to negative 4. Cool? Easy, easy, right, guys? Okay, guys, so now we're going to look at different cases or different examples with equations. Okay, guys? So let's just look into that. All right, guys. So now, guys, we're going to be looking into all the different possibilities and cases in terms of looking at linear equations. Cool? So we're going to look at this here. It says we can maintain the equality or balance in an equation by adding the same quantity to both sides of the equation, subtracting the same quantity from both sides of the equation, multiplying both sides of the equation by the same quantity, and dividing both sides of the equation by the same quantity. Cool? So we're going to look at that now, and we're going to look at all the cases: adding, subtracting, multiplying, and dividing. And in solving linear equations, guys, remember that the left-hand side is equal to the right-hand side. Cool? All right, so we're going to look at the first case here. And the first case is equations containing addition. Cool. So in this case, we'll have x plus 2 is equal to 7. And we have, right, that's the equation we have. And of course, we need to solve for x. So the first thing we can do is for this one here, we can subtract 2 from both sides of the equation. Let me write that better. So we can subtract 2 from both sides of the equation. So you'd get x plus 2 minus 2 is equal to 7 minus 2, and you end up with x is equal to 5. Cool, so that's one way to do it. Or, right, you notice there's an or here, guys. Or we can say we're going to carry this 2 to the right hand side of the equation. Cool, so we can say x is equal to 7 minus 2, and remember, when you carry a number to the other side of the equation, it ends up being the opposite sign. So x is equal to 7 minus 2, which is 5. Cool, pretty simple, right? It's so simple, guys. So let's look at the other cases now. All right, guys, so now we're looking at case 2, which is equations containing subtraction. All right, guys. So for the first thing here, guys, what we can do is we can add positive 3 to both sides of the equation of the equation. So we're going to end up with x minus 3 plus 3 is equal to 8 plus 3, and then these two would cancel each other, and we get 8 is equal to 11. So that's one way to do it, guys. Or we can say we can carry um, the negative 3 to the right side of the equation, and we're going to end up with x is equal to 8 plus 3, because when we carry this negative 3 to the right side of the equation, it ends up being a positive 3, right? Because the signs change, and we're going to end up with x is equal to 11. Cool. So those are two ways to do it. Then we looked at case 2, we're going to look at case 3 now, and it says equations containing multiplication. So we're going to be looking at multiplication in this case, guys. And for this for the first thing, for the first example, we can actually divide both sides. Divide both sides by 5. Cool. So we can say this is divided by 5 and this is divided by 5. So we divide both sides of the equation by 5, and then we're going to end up with x. This 5 cancels this 5, and 5 goes into 35 7 times. So x is equal to 7. Cool. So that's one way we can do it. Or guys, we can just simply divide the right side of the equation by 5. So here, this 5 would come down here, and you'd end up with x is equal to 35 divided by 5, and you'd end up with x is equal to 7. Cool. Very simple, guys. So simple. So let's look at case 4 and 5 now. We're going to look at all the cases, all the possibilities of an equation. Cool. All right, guys. So now we're going to be looking at these two different cases here. And the first one we're going to look at is equations containing division. Cool. So for this one, guys, we can actually multiply both sides by 6 for this example here, and we'd end up with x over 6 times 6 is equal to 5 times 6, and this would be equal to, these 6's would cancel, and you would give us x is equal to 30. Cool. So that's one way. Or you can simply cross multiply here, guys. You can multiply that 6 by the 5, and you get x is equal to 5 times 6, so x is equal to 30. Cool. So that's how we handle equations with division. Or well, sorry, we're looking into the second case here, the next case, the fifth case, which is equations containing the unknown on both sides. Cool. So when you look at these two equations, guys, you can see here it's the same equation, but the unknown, the x is on both sides of the equation, right? So we can take our time, right, and use the simple steps here, and we can subtract 2x from both sides of the equation, and we end up with 5x minus 2x minus 3 is equal to 2x minus 2x plus 9, right? And then we're going to end up with 3x minus 3 is equal to 9. Cool. So, and then the next thing we can do here is add 3 to both sides. So we can add 3 to both sides of the equation, and we end up with 3x minus 3 plus 3 is equal to 9 plus 3, and we're going to end up with 3x is equal to 12, right? Then the last thing we can do here, guys, is divide both sides by 3, and we're going to end up with, I'm going to write up here, 3x over 3 is equal to 12 over 3, and x, these three cancels. These 3 cancel each other, and 3 goes into 12 4 times. So x is equal to 4. Cool. So this, guys, is the long way. Cool. And I personally would not do it this way because it takes really long. So for this one over here, you just simply solve it as simply as you can. So for this one here, I would have 5x minus 2x. So I brought the 2x over to the left side of the equation, and I'm going to bring the 3 over to the right side of the equation, and I'm going to get 9 plus 3. Then I'm going to have 3x is equal to 12. Then I can simply have x is equal to 12 divided by 3, and x is equal to 4. So I would actually do it this way, guys. I just have to break it down as simple as possible for you guys, but I personally would just solve the equation without subtracting and adding from both sides. But I had to show you both methods to show you as simple as possible how we manage these equations. All right, guys, so we're going on to case 7. Sorry, we're going on to case 6. All right, guys, we're going to move on to case 6 now. That's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.